So you're into smart homes, right? You've seen that magic when all your devices just work together. But have you ever stopped to wonder how it all happens? There's this incredible invisible network working behind the scenes. And in this explainer, we're going to dive deep into the hidden language that truly powers our smart world. Just take a look around your house. You've got that smart plug over there, maybe some solar panels on the roof, your security camera system. I mean, what could they possibly have in common? They all seem like they're from totally different tech worlds, but believe it or not, they all share one powerful secret. Yep, they're all speaking the same secret language. It's a protocol that lets them all chat with each other instantly, reliably, right under our noses. And today, we're going to pull back that curtain and show you exactly what it is. All right, let's start by exploring this unseen network. I think you'll be genuinely surprised by just how many devices you probably already own that are completely fluent in this language. I'm talking about stuff like sawn-off smart plugs, especially if you're a DIY kind of person who's flashed them with custom firmware like Tesmata, or Shelly relays, which have supported this stuff right out of the box for ages. It's even in high-end gear like Victron solar inverters, powerful software like Blue Iris, and even network hardware like MQTT routers. This is not some obscure tech. It's already everywhere. So, what is this mystery protocol that's tying all these different gadgets together? All right, time for the big reveal. It's called MQTT. Okay, MQTT stands for Message Queuing Telemetry Transport. I know, that is a total mouthful. But don't worry about the name. The only parts you really need to remember are machine-to-machine and extremely lightweight. It was literally designed from the ground up for the Internet of Things, for all those little devices that need to send small bits of data super efficiently without burning through battery or bandwidth. The best way to think of it? It's basically WhatsApp or Messenger for your devices. It is that fast. It's all about real-time instant communication. A sensor detects motion and boom, the message is delivered to everything that needs to know. No lag, no frustrating delays. And here's the wild part. This is not a new kid on the block. MQTT was actually invented way back in 1999 by folks at IBM. It became an official industry standard in 2014, and today we're on version 5.0, which has all sorts of great improvements for handling huge systems with thousands or even millions of devices. So we know what it is, but how does it actually work? This is where the magic really happens, and it's all built on a model that is just beautifully simple. Instead of every device trying to talk directly to every other device, which would be a total mess, MQTT uses this brilliant model called publish/subscribe, or PubSub for short. Here's how it works. A publisher, let's say it's a temperature sensor, sends out a message. But here's the key. It doesn't send it directly to your phone or your smart display. Nope. It sends it to a central hub called a broker. Then, any other device that has subscribed to that sensor gets the update from the broker. This broker is the heart of the entire system. Think of it like the air traffic controller for all your device messages. For all of us home automation fans, there's a hugely popular free and open source option called Mosquito. You can run it on pretty much anything, a tiny Raspberry Pi, a home server, you name it. So how does the broker know where to send everything? It uses something called topics. A topic is just like an address or a channel name for a specific piece of data. For example, your garage door sensor might publish its status, open or closed, to the topic Home Assistant/binary sensor/garage door. Then, your dashboard simply subscribes to that exact topic to get the updates. Oh, and a little pro tip for you. Always use lowercase and avoid spaces in your topics. It'll save you a lot of headaches down the road. But hang on, what happens if a message gets lost? I mean, this is Wi-Fi we're talking about. Well, MQTT has this covered with a feature called Quality of Service, or QoS. You get to choose a level. QoS 0 is fire and forget. It's fast, but there's no confirmation. QoS 1 guarantees the message arrives at least once, though you might get a duplicate. And then there's QoS 2, the most reliable. It uses a whole handshake process to make sure the message arrives exactly one time. For critical things, you'll definitely want to use QoS 1 or 2. And check this out. Here's a really clever feature, the last will and testament. When a device connects, it can register a last will. So if that device suddenly drops offline, say a smart plug loses power, the broker automatically sends out its last will message to a specific topic. Something like garage_plug is now offline. It is a fantastic built-in way to create a self-monitoring system. Okay, that's enough theory. Let's look at how all this comes together with the real-world devices that we're using every single day. A perfect example of this is comparing brands like Sonoff and Shelly. with a lot of sawn-off stuff, the DIY community will flash custom firmware like Tesmata onto the device just to enable MQTT. Shelly, on the other hand, totally embraced local control early on. MQTT is supported right in their stock firmware, no tinkering required. It's that classic choice, the tinker-friendly option versus the simple plug-and-play one. And this is where MQTT becomes truly powerful. It is the absolute backbone for platforms like Home Assistant and Node-RED. They act as the master subscriber, listening to everything happening on your network, and the master publisher, sending out commands to control it all. MQTT is the central nervous system that makes all of those complex, amazing automations possible. So let's bring it all home. We've seen what MQTT is, we've seen how it works. But why? Why has this protocol that's been around for over 20 years become the absolute standard for the entire Internet of Things? It really just comes down to 4 key things. 1, it's extremely lightweight, so it can run on the tiniest little microcontrollers. 2, it's efficient, which minimizes network traffic and saves battery life. 3, it's reliable, thanks to those quality of service levels we talked about. And 4, and this is a big one, it's decoupled. This means publishers and subscribers don't need to know anything about each other. You can add or remove devices from your network without breaking the whole system. It's just incredibly flexible and easy to scale. So it turns out this unseen language has been connecting your world all along. It's the invisible thread weaving all your smart devices into one cohesive, intelligent network. And now that you can actually see it, now that you get it, what will you connect next?